Greetings, Dr. Dan with Optimal Optics here to introduce Unit 14P, word problems on microscopes and telescopes. I'm assuming you have already viewed Unit 14. If you have not, this would be a marvelous time to do so. Question 1, if the focal length of a microscope's objective is 16 millimeters and the focal length of its ocular is 25 millimeters, what is the magnification? So the focal length converted to meters is 0.016 meters for the objective. And the power of the objective, which is f1 in our formula, is 62.5 diopters. The focal length of the eyepiece or ocular is 0.025 meters. Therefore, its power is 1 over 0.025, or 40 diopters. Delta, you have to assume, is 0.16 meters. If you're not given it, that is the standard optical tube length. So the magnification formula equals minus delta f1, f2 over 4. We plug in our numbers. And we find that the magnification equals minus 100x. Question 2, a microscope has an ocular marked 15x and an objective with a focal length of 4.5 millimeters. What is the total magnification if the objective forms its image 16 centimeters beyond its secondary focal point? Round your answer to the nearest tenth. So recall, the magnification of a lens whose object is at its focal point is f over 4. And the object for an ocular in a microscope is at its focal point. That's where the objective forms its image. So we can calculate the power of the ocular because 15 equals f over 4. And therefore the power of the ocular is 4 times 15, which equals 60 diopters. And that's f2 in our magnification formula. Magnification for a microscope. The focal length of the objective we're given is 4.5 millimeters. We convert that to meters, 0.0045 meters. And we can calculate the power of the objective with the formula power equals 1 over the focal length in meters. This will be f1 in our microscope magnification formula. And we find that f1 equals 222.2 diopters. The optical tube length is 16 centimeters. It's given. The optical tube length is the distance between the secondary focal point of the objective and the primary focal point of the ocular. So we'll plug in our numbers into the magnification formula. For a microscope, you can use microscopes to look at plant cells and animal cells. There was a cell that accidentally stepped on the front of the foot of her brother, and he called out, "MITOSIS." And the magnification equals minus 533.3x. Question 3, a microscope has an ocular having a focal length of 12 millimeters and an objective with a focal length of 3.2 millimeters. If the objective forms its image 16 centimeters beyond its secondary focal point, find the total magnification. So the focal length of the eyepiece or ocular is 12 millimeters, which is 0.012 meters. The focal length of the objective is 3.2 millimeters, which is 0.0032 meters. And we're given in the second sentence that delta is 16 centimeters or 0.16 meters. So the power of the objective, which is f1, is 1 over 0.0032. And that equals 312.5 diopters. The power of the eyepiece or ocular, f2, is 1 over 0.012. That equals 83.33 diopters. magnification is minus delta f1, f2 over 4, and we'll plug in our numbers. By the way, if you're looking at an amoeba under the microscope, remember that amoebas are very poor at math because when they're supposed to multiply, they divide. So the magnification equals minus 1042x. Question 4. What is the distance between the lenses of a Galilean telescope if their powers are plus 4 and minus 10 diopters? What is the magnification? So remember, a Galilean telescope has a convex objective lens and a concave ocular. So we're given that the power is plus 4, therefore the focal length of the objective lens is 1 over 4, which is 25 centimeters. And its secondary focal point is that far away from the lens. That's the objective. The focal length of the eyepiece will be 1 over minus 10. So that's minus 0.1 meters or minus 10 centimeters. It's measured from the primary focal point, FE, to the lens. So there's the 10 minus 10 centimeters. So you can see that the distance between the two lenses must be 15 centimeters. That answers the first question. Now we're going to determine the magnification with the magnification formula for a telescope, which is minus FO over FE. That's minus the focal length of the objective over the focal length of the ocular, and we get plus 2.5x.